Alright people, this will be a quick video on these 9.3 rational equations and inequalities notes. This is a pretty easy set of notes, so hopefully we can get through them pretty fast. Alright, so starting off, we're just going to solve some rational equations, and it says always check for the undefined values, so extraneous solutions. And let's get started with number one. Obviously we want to check for values x can't be. And immediately off the bat, we know that x cannot be 0 because we can't divide by 0. So now that we have that out of the way, let's move this 5 over 4 to this side so we can isolate our x. So we have 6 over x is equal to negative 12 over 4. Cross multiply gives us 24 equals negative 12x. And dividing by negative 12, x equals negative 2. Alright, and negative 2 is not 0, so this is a possible solution. So let's box our answer. Next one over here, we have x minus 18 over x equals 3. We want to get rid of this x on the bottom, so let's multiply by x on both sides. So we're just going to do like this and like this. And then that will give x squared minus 18 equals 3x. And this looks like a quadratic, so we're going to move this 3x over, so that gives us x squared minus 3x minus 18 equals 0. This is easily factorable, so this is going to give x minus 6, and then x plus 3, which is going to equal 0. That gives us two solutions, x equals 6 and x equals negative 3. And as we can see on the top, the only extraneous solution is if x would be 0, so these are both solutions. Nice. Next question. Alright, here it's a little more complicated, but as you can see, we have some like terms here. So we're just going to subtract and move this to that side, which is going to give us 1 minus x over x minus 1 equals x over 6, like this. And we're just going to cross multiply, so we have 6 times 1 minus x is equal to x times x minus 1. So we have 6 minus 6x is equal to x squared minus x. Once again, this does look like a nice easy quadratic. So if we just move some things around, we have x squared plus 5x minus 6 equals 0, which is going to give us x plus 6. And then x minus 1 equals 0, don't forget that, and this is going to give us x is equal to negative 6 and 1. However, we need to be careful. If we look at our extraneous solutions here, x cannot equal 1. So we're going to have to cross out this answer. And alright. So that means our answer is going to be x minus 6, and x equals 1 is not going to be one of the answers. Alright, number 4, 5x over x minus 2 is equal to 3x plus 4 over x minus 2. First thing to note is our extraneous solution, so x cannot equal 2 here. Then we can do cross multiply and divide. So really, we can just multiply both sides by x minus 2 over 1. Because if you multiply both sides by something, it's still equal. So then these will cancel out. So we have 5x equals 3x plus 4. 2x equals 4. X equals 2. So that's our answer. Just kidding. X can't equal 2. So the correct answer is no solutions. And there we go. Alright, we're going to keep going. So here you want to get out the fraction. The biggest degree on the bottom is x squared. So we're going to have to multiply both sides by x squared. Like this. And we should make note that x can't be 0. And this will give us 4x plus 6x squared equals 1. This is another one of those easy quadratics. We can just do it like this. And we can have, actually, this is not factor. So we're going to use our nice, easy quadratic equation. Negative b plus or minus square root of b squared minus 4ac over 2a. So x is going to be negative 4 plus or minus square root 16 minus 4 times 6. And then c is just negative 1. 2a, which is going to be 12. And if we simplify this, this should be x equals negative 4 plus or minus 40, yeah, around 40 over 12, which gives x equals, remember we can take a 4 out actually, so this is going to be, it's 8 times 5, no, 4 times 5 is 2 to 10, like this. We can cancel some stuff out here. If we take out the excuse me, if we take out a 2, we're gonna get negative 2 plus or minus rad 10 over 6, and this is our answer because it's not 0. Alrighty, let's go over to number 6. We have these two on the bottom, so we're going to have to do some factoring. So 4x over x plus 3, x minus 2, that's pretty easy, equals 7x times x minus 8 appears x plus 3. Let's make note of our extraneous solutions right now. So we can have x equals negative 3, 8, or 2. And it appears that both sides have an x plus 3, so we can multiply both sides by x plus 3 over 1. And this will cancel out, giving us 4x over x minus 2 equals 7x over x minus 8. Cross multiply, so we have this. And then we can multiply out. X equals negative 14x here. So if you just combine like terms, add the move this 14x to this side, we get 3x squared actually equals, and 32 minus 14 is 18, negative 18x. And from here we're going to do 3x squared plus 18x equals 0. Divide both sides by 3. Take out an x. This is our final. So it gives us the solutions. X equals negative 6 and 0. And that is not one of our extraneous solutions, so this is good. And these are our answers. Alright. The next part of the notes is going to be solving rational inequalities, and the method we use in 3+ is called critical points method. It has 3 steps right here. The first one is you want to solve it directly. I'll show you what this means in a second. Then you find any vertical asymptotes, so that's our second critical point. I'll also show you this in a second. And then you want to sketch the number line. It helps you visualize, and then you want to find those areas. Alright. So let's get started with number 1. We want to do our first step. Let's find CP number 1. Let's just do step 1. So we want to solve the inequality directly, so we're going to make it like an equation. We're just going to say, what if it's equal? Because since we know that this value must be greater than 3, if we set it to be equal, that will be one of the boundary areas. So if we just solve this out, we get 3 equals 3 times x plus 6, x plus 6 equals 1, x equals -5. So our first major point, or critical point in this case, is going to be here. So then the next one is find a vertical asymptote. So number 2, our vertical asymptote is obviously going to be x plus 6 because it can't be -6 on the bottom. So x equals -6 is our next one. That's number 2. And we don't have any more critical points other than that. So we're going to graph our number line. Our number line would look like this. And let's mark -5. Oops, that should be -6 actually. This will be -5. And let's think about what points we should put here. Is it going to be closed or open? Well, we know x can't be -6, so that's the first easier one. We know it's going to be open there. And for -5, it will actually be open because the original one says it's got to be greater than, but we found 5 by making it equal, so we know it won't be equal to 5, so we just put an open hole there. Now we have 3 areas to check. We have this one, and this one. First we're going to check outside over here, and we can just use the point 0. So what if x equals 0? X equals 0, we're going to get 3 over 6 is greater than 3, so we have 1/2 is greater than 3. Obviously that is not true, so it's not here. Anything greater than -5 will not work, so why don't we try something like -7. So x equals -7, so we have 3 over -7 plus 6 is going to be -1. It's greater than 3. -3 greater than 3, obviously not, so this doesn't work either. And now we have to check this middle one, so we're just going to do -5.5. And if we use -5.5, we get 3 over -5.5 is going to give us positive 0.5 greater than 3. We know, and obviously we know that 6 is greater than 3. So this middle area works, which means our final interval, because it wants us to answer in an interval form, we know that it's going to be x. The domain is going to be here. It's going to go from -6 to -5, and it's open on either side. This is our final answer. All right. And you want to graph it, so we're just going to graph it right there. And this is what our graph will look like. It's a little messy, but it works out just fine. Okay, next problem. We have 4x minus 3 over x minus 4 is greater than or equal to 2. So, number 1, we're just going to solve it directly. And since it says equal or equal to, we're allowed to equal to, so this makes our job actually slightly easier. So we have 4x minus 3 equals 2x minus 8. We have 2x is equal to -5. X equals -5 over 2. So this is our first critical point. Alright, then we're going to have our vertical asymptote at x equals 4. So x equals 4 is our second one. Because that's a vertical asymptote, it will never reach that value. And those are our only 2. So we're gonna draw our number line now. Here and here. We're just gonna do 4 first actually, and then -5 over 2. Obviously, we have our values in here, our values here, and our values here that we need to test. So if we test boundary point A, we're just going to use -3 as an example. So if x equals -3, we have x equals -3 first of all. we're gonna get negative 12 minus 3 over negative 7 is greater than or equal to 2. Oh, sorry, we need to define our boundary points first. Okay, x cannot touch 4 because it's a vertical asymptote. Vertical asymptotes will always have an open circle, and it can equal negative 5 over 2 because it's greater than or equal to. So this is what our boundary point is going to look like here. Next, let's just continue down here. We'll have negative 15 over negative 7 greater than or equal to negative 2. So this gives 15 over 7 greater than or equal to negative 2, and this is true. So we know that we are good on this interval. So let's graph that. Like so. Then we have this middle interval. We'll try 0 because we know it's in between there. So we have negative 3 over negative 4 greater than or equal to negative 2. This is obviously not true, so this middle doesn't work. Now let's try 5 because it's on the outside of this interval. It's outside the 4. So we're going to have 20 minus 3 over negative 1. Oh, actually no, over 1. My apologies. Greater than or equal to 2. And this is obviously true because 17 is greater than 2. So this works. So our interval, our interval out here works as well. So if we are going to say, we're going to say that x is going to be less than or equal to negative 5 over 2. Oops, that is disgusting. Negative 5 over 2. Or it's going to be x is going to be greater than 4. And this is our final answer. And oh yeah, I should note that we do not want to use interval notation. My apologies. So this is not correct. We're gonna have to use negative 6 like this. This is the proper notation for when solving inequalities because it's an inequality, not a range. Alright, so I'm gonna leave 3 and 4 for you guys because those are relatively similar to the one we just did. And I'm gonna do 5 because it's a little more complicated. Alright, so first step is always to solve it directly. So we have 3x over x plus 2 minus 2 over x plus 4 equals, equals 7. So we're gonna combine our like terms. Actually, we're just gonna multiply both sides by x plus 2 times x plus 4. That will make things easier. So it's gonna be 3x times x plus 4 minus 2 times x plus 2 equals 7 times x plus 2 times x plus 4, like this. And this becomes 3x squared plus 12x minus 2x plus, minus 4 equals 7 times x squared plus 6x plus 8. We're going to do 3x squared plus 10x minus 4 is equal to 7x squared plus 42x 56. Alright, so if we send these all over to one side, we're going to get 7x, whoops, oh my god, 4x squared plus 32x, yep, and plus 60 equals 0. We can divide everything by 4 here, so x squared plus 8x plus 15 equals 0. And this is pretty easy. It's going to be x plus 3 and x plus 5 equals 0. So x equals 3 and 5. So those are our first 2 critical points. Our 2 vertical asymptotes are going to be x equals -2 and -4. And now that we have all 4 of our critical points, we can start plotting. So I'm just going to use some of this space up here, like this. So this will be pretty big. Let me actually move these over vertical asymptotes at x equals -2, -4. Alright, the biggest number that we can't have on this side is -4. We're gonna have a -2 here. We're gonna have a 3 and a 5. And remember, since we solved it directly and it's a greater than or equal to, x is able to be allowed to equal 3 and 5. So we have closed dots here on these intervals. And then, oh shoot, wow, I just noticed a big mistake. Apologies. I forgot to put negative signs in front of these. This is -3, -5. I don't know what I was thinking. But anyway, continuing on. -4. Actually, we'll put -5 here. -4. Then we have a -3 and a -2. Okay, but the point still applies. It can be on these intervals here, and since these are vertical asymptotes, it can't be here. All right, we have to check this here, this, and this interval. There are 5 intervals to check, and you must check every single one of them. I know it's very tedious, but that is how you have to get full points. If you don't do that, you do not get full points. All right, so let's do x equals -6, and that's going to give us -18 over -4 minus 2 over -2. Is this greater than or equal to 7? Well, let's see. We have -9 over -2. Then it's a -2 there. It's a -2 here. Greater than 7. 11 over 2 is not greater than 7. This does not work. So these values out here, we do not need to worry about. What about 5 and 4 between these two? So we have x equals -4.5. And we'll actually just plug this straight into a calculator. So 3 times -4.5 and -4.5 plus over -5.2 minus 2 over -4.5 plus 4, and this is equal to 47 over 5, which is in fact greater than 7. So we know that in this value we have it working. Now we have to try here. We're going to use -3.5. And what does this give us? We just use the calculator once again, because this is going to take way too long freehanding it. This gives us 3, which is not greater than -7. So this does not work out. We don't have any values in here. Next one we have to check is up here. So we have x equals -2.5. Plugging into calculator again. This gives us 41 over 3, which indeed is greater than 7. So we have values here. And then the easy one to try on the very end is just 0. So we have, the first one's going to be 0. The second one is going to be -2 over 4, which is not greater than 7 or equal to 7. So we don't need to worry about things here. Which makes our final answer going to be equal to -5 greater than or equal to, less than or equal to x, which is less than 4, -4, or -3 is less than or equal to x, which is less than -2. And this is our final answer. You need to have both to have a complete answer. Alright, thank you for watching, and I'll see you in whatever next video I make. Thank you.